This video is on molecular formulas and how to calculate them. Make sure you're taking really good notes and listening to everything that's being said, and you have your calculator and periodic table out. Also, make sure you've already watched and understand the empirical formula video. That is very important to doing this because you have to know how to calculate an empirical formula before you can calculate a molecular formula. So an empirical formula is the simplest ratio of the elements in a compound. So it's going to be like your most reduced form. Your molecular formula is going to be the actual number of elements in a compound. So it could be the same as your empirical, or it could be a multiple of that. So for instance, you could have an empirical formula that is NO2. Okay, that's the simplest ratio. You have one nitrogen for every two oxygens. You can't reduce those numbers anymore. But the molecular formula might be N2O4. So now it's the actual, and it's a multiple of that. So your ratio is 2 to 4, which is not the simplest form. So it's a multiple of the empirical. It could be the same. Okay, and when it is the same, all that means is it's a multiple of 1, because when you multiply numbers by 1, they do not change. So the first thing you need to do to calculate your molecular formula is actually find your empirical formula. You can't find out how many times it's multiplied if you don't know what that starting thing is. So those steps 1 through 3 for your empirical formula are what you do first. So that's why these steps are numbered starting with 4. Okay? So you have the mass of the empirical formula. That's the first thing you need to find. So in my examples up there in green, I would find the mass of NO2. So I'd add up 1 nitrogen's mass and 2 oxygen's mass. Then I would take the given mass. You're going to have to be given the mass of the molecular formula in your question. And you would take that and you would divide it by the calculated mass, the one you just found for your empirical formula. And then the last thing would be to do whatever you get for that answer for number 5. You're going to multiply all your subscripts by that number. Okay, so this will make a little bit more sense as we do a couple examples. So the first example is set up so that you already know the empirical formula. So I've already done for you steps 1 through 3. So we just get to practice the new steps 4 through 6. So it says assume a compound has an empirical formula of CH. The molar mass of the molecular compound is 78 grams. What's the molecular formula? So kind of to lay it out for you, we have an empirical formula of CH. Okay, we need to know the mass of that. That's step number 4. All right. We know, or we need to know our molecular formula. Okay, and we want to know, or we know the mass of that actually. That's what is in the problem, this 78 grams. Okay, so in order to find this molecular formula mass, this question mark, okay, we need to first find the mass of CH. Okay, so that's step number 4. So I'm going to write out my elements. I have 1 carbon, I have 1 hydrogen. So carbon's mass is 12.01. That's on the periodic table. So times 1 is 12.01. And remember, at this point, you might not have to write this out. You might be able to just do this in your calculator. The hydrogen's mass is 1.01. So I need to add these up to get my total mass. And that would be 13.02. Okay, so I've just found my empirical formula mass. Okay, so at this point, I need to now do step number 5. Divide the given mass, so my given mass is 78, by the calculated mass, the one I just found, 13.02. So I'm going to do 78 grams divided by 13.02. Okay, we want to know how much bigger is 78 grams. So when you divide this out, you're going to get really, really close to 6. Okay, and these numbers might not be exactly whole numbers, but they're going to be extremely close. If they're not, we'll we'll talk about that actually in the next example. So what this means is, what this 6 tells me is that my molecular formula, this one right here, is 6 times larger than the empirical. Its mass is 6 times larger, so its formula should be 6 times larger. So my molecular formula, I have to take all my subscripts and multiply them by 6. Well, my subscripts for CH are 1 and 1. So I'm going to multiply them by 6. So it would be C6H6. And this is your answer. Okay. So we'll do one more example in this next one. We'll do it start to finish. So we'll actually first find the empirical formula. So it'll be a good review of the last video. And then we'll find the molecular formula after that. Okay, so let's read our question. It says, find the molecular formula for a compound that contains 43.6 grams of phosphorus and 56.4 grams of oxygen. The molar mass of the compound is 28.0 grams per mole. So we need to find the empirical formula first. So if you go back in your notes to those steps, step number 1 is changing your given to moles. So I have 43.6 grams of phosphorus. All right, and we're going to go grams to moles. 1 mole of phosphorus is 30.97 grams. Okay, grams divide out. So when you divide 43.6 by 30.97, you get 1.408 moles of phosphorus. Okay, so we do the same thing for oxygen, convert it to moles. So 56.4 grams of oxygen. So grams divide out, so bottom. And 1 mole of oxygen, there are 16.00 grams. Okay, so when I divide this, 56.4 divided by 16, I get 3.525. Okay, so that's step number 1 for our empirical formula. The next step is to compare them by dividing each one by the smaller amount. So we're getting a ratio here. So the smaller one is 1.408. So I'm going to take both of these and divide them by that number. So I'm going to divide by 1.408. So this one, divided by itself, that's going to be 1. Okay? When I divide this one by 1.4, okay, I get really, really close to 2.5. Now in the last one, it was really, really close to 6. Okay? Now it's not as close to a whole number. It's like right in the middle. So what this tells me is my ratio, for every 1 phosphorus, there's 2.5 oxygens. Well, we can't write those numbers as subscripts. We have to have whole numbers. So we need to be able to multiply these two to get whole numbers. So what could I multiply them both by? Same number to multiply them both by to get a whole number ratio. Well, if I multiply them both by 2, so times 2, this is going to give me 5. Times 2, this one's going to give me 2. There's a whole number ratio. For every 2 phosphorus, there are 5 oxygens. So my empirical formula is P2O5. Okay? So now we need to find our molecular formula. So we need to find the mass of this. So we're on to step number 4. So the mass of this, I have to add up 2 phosphorus and 5 oxygens. Okay? Write this out if you need to, so pause the video if you need to, or try this in your calculator real quickly. So I found the mass to be 141.94 grams. So my molecular formula is what we want to know. Okay? And we know the mass of this because it was given in our problem. Oops, I don't even have to scroll up. Right here. 284.0 grams per mole. So I need to now divide them. So 284.0 grams divided by 141.94 grams. So grams divide out. And when you divide this, you get 2. Really, really close to 2. So that means my molecular formula is twice as big as my empirical formula, just like the mass is twice as big. That's what we just found out. So my molecular formula would be P4, I'm going to multiply my subscripts, O10. So I took these two numbers and multiplied them by 2. Okay, so this is my answer. And that's how you calculate a molecular formula.